Saxon Algebra 1, Lesson 62. We're going to talk about square roots. I was so excited to learn square roots when I was a student because I loved making the little that thing. That's called a square root sign. It's called a radical, and later I'm going to refer to it as a pig house because I have some connections to the story of the three little pigs when we deal with these little guys. And so I often refer to this as a pig house. When you go to college, please don't call it a pig house. Just do it in your head. Don't tell your teacher that you think of them as pig houses. Okay, and we know that this sign is officially called, like I said, this is a square root. Sometimes we put a little number there. This one is called a cube root. And then if we get up into like big roots like this, we call that a seventh. Oops. Root. So square root, cube root, and then we just say like a fourth root, a fifth root, a sixth root, etc. Right? And I'll just put X's in there to fill them in. Now, we also know that we can raise things to a power, right? We can call that an exponent. And here's the cool thing. These guys cancel each other. Just like multiplication and division are canceling partners and adding and subtracting are canceling partners, roots and powers, or roots and exponents, cancel each other out. So if we take the square root of a number and then square it, we get the original number back again. Those two cancel each other out. Cool, right? All right, we're going to learn how to use the calculator to do these, but honestly, we're not going to do a lot of that. We in high school math, I firmly believe in staying away from calculators as much as possible, because what happens is that when we start fiddling around with calculators, everyone forgets about the actual math and is just thinking about which buttons to push. It happens to me too, so I know it's true. But it's completely distracting, and it gets us away from understanding the whys of the way we do math into just the practical problem of which button do I push, all right? So that is why I stay away from it. When you go to college, your instructors will not assume that you have lots of practice with calculators. They'll explain to you how to do what you need to do, and I'll explain to you how to do what we absolutely must do, but we don't do a lot of it. The calculator that I would like you to use is the scientific calculator on a smartphone. You do not need to get a graphing calculator or a tablet. Oh, my dog's barking. I have to go let her out. Hang on. Okay. Oh, yeah, I spelled that right. You don't need to get a graphing calculator, a big old fancy one, but I do want to make sure that you have the scientific calculator app on a smartphone or a tablet. Wait right there. Talk amongst yourselves. I'm coming, dog. Okay, I'm back. I'll have to go again in just a minute and let her back in, but you know, nice to know I have my priorities straight, right? Okay, so if you want to find the square root on a calculator, if you want to calculate it, you enter the number. We're going to enter 18. You put that in, and then you hit the square root button, and I believe it has an X in it. And then you hit equals, okay? These, you just enter them in. And the answer that you should get is 4.2426080687. Now, you may or may not have a calculator with you right now, but I bet that if you do, you're watching me on the phone. So you may have to do this later, but make sure that you try to do this. Enter the two numbers, then hit that button, hit equals, and see if you get that. You might not even have to hit the equals. You may just get it right away. If you don't have a scientific calculator, you need to have the kind that go landscape. right? If you have a calculator on your phone that just goes portrait, that's not enough. You need to get all of those functions, okay? If you need any help finding the right app, let me know, and we'll get you set up on whatever device that you use. But make sure that you can find the square root of 18, and then you're supposed to take it to 5 decimal places. This is what your calculator will show you. And then you're supposed to round it to 5 decimal places. And that's easy. We just count 1, 2, 3, 4, 5. That means this decimal place, and we look at the next one to tell us what to do. That is a 6, so that means round up. Oh, wait. I copied it wrong. 4.24264. Okay, so I lied. This is the digit that either rounds or stays, and the 0 is what tells us. 0 tells us to stay, so our final answer is 4.24264. There it is, rounded to 5 decimal places. That's the right answer. Okay, so make sure you know how to do that on a calculator. We're not going to spend a lot of time doing it, but I want you to know how. Armed and dangerous. That's my philosophy. Okay, example 62.2. Use a calculator to determine the 2 square roots of 10 to 6 decimal places. Okay. What that means, Tessa, are you going to let her in? Thank you so much. Tessa's letting Gracie back in. She was barking. Yay, Tessa. Okay, so what you do is you just hit this, you enter 10, hit the square root key, hit equals if you need to. Then that value is positive and negative. So we're supposed to round it to 6 decimal places. So we round just like we always round. And the number that you should get for your answer is, I'll copy it down. And again, make sure you work this through before you do the homework for this lesson. These are the rounded values. And remember, we always have positive and negative roots because square roots mean that the 2 numbers multiply together to get the original number. Hi, Grace. Did you come back in? She's really excited to see me. Hi. Hi. I missed you too. Yes, we went on ahead without you. I'm sorry. So if we multiply this times itself, we'll get positive 10. If we multiply this times itself, we'll get positive 10. So that's why we have 2 roots, a positive and a negative. Okay. Example 62.3. This is the most valuable problem of the day. Without using a calculator, write the squares of the counting numbers 1 through 20. All right. Write like I'm doing. We're going to fill in the answers later. And then do this. Skip 16, 17, 18, 19. All right? Okay, what we want to do is we want to memorize some of these, what we call perfect squares, because they're really useful to us in lots of different calculations. And honestly, you already know a bunch of them. You already know that 1 times 1 is 1. You know that 2 times 2 is 4. You know that 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. All right, I'm going to stop talking. Well, here's what I want you to do, though. Make this into a better chart so that the numbers have their own little sections. And if you want, you can write equals so that you can tell what's going on there. Okay. Now what I want you to do is fill in this second row. You should know all of these by heart because they're just times tables. So go ahead and fill them in while I do it without talking. Okay, so the first two rows are the easy ones because I'm assuming you already have your timetables pretty well memorized through 100. Now, 11 through 15 are a little shakier, but I'm going to give them to you. Remember, you can always calculate them yourself. 11 times 11, 12 times 12. You can calculate them easily yourself if you ever need to, but it's nice to have them memorized. 11 is 121. 12 times 12 is 144. Let's skip up to 15. That's 225. Okay? Now, these two are confusing because they both have the same digits, just in a different order. This one is 169, and this one is 196. If you can remember that it's a 6 and a 9 and a 1, then you can remember which one is 13 because that's obviously going to be the smaller number. So make the 6 and then the 9, and this is the 9 and then the 6, okay? So these are pretty easy to memorize. 16, 17, 18, and 19 are a lot harder to memorize, and so I don't want you to worry about them, but I want you to have them right here. And remember that you can calculate them any time just by doing the multiplication by hand. 16 squared is 256. 17 squared is 289. 18 squared is 324. Don't you wish I could just sit with you while you're doing your homework and just tell you what all the facts were? This is 361. And then 20 squared is easy. That's 400. Right? It's really important that you learn those. Yay. All right. The next problem sounds really complicated and weird until you actually do it, and then you realize, oh, that's not bad. And it's going to be helpful if I have this page in front of me. Okay, we're supposed to find my overflow book. It says, without using a calculator, determine between what two consecutive integers the square root of 10 lies. Okay, the square root of 10. 10 is not a perfect square, right? It's not one of these numbers. And so its root is not going to be a whole number. But we're trying to figure out where does it fit in. Well, it's 10. The square root of 10 is going to be somewhere between these two, right? Because it's bigger than 9 and less than 16. That's where 10 falls. So that means the square root of 10 is going to be between 3 and 4. That's the right answer for this problem. And this is 62.4. Okay, so when you get these problems where John gives you a random number and says between which two integers does it fall, just compare that number to this chart and go, okay, let's compare where all it falls with these perfect squares. Like I said here, 10 is between 9 and 16, so the square root of 10 is going to be between 3 and 4. All right? I hope that makes sense. It's so much easier than it sounds like it is. All right, higher order roots. These are some memorize-y guys. The third root of 8 is 2. Memorize that. 2 times 2 times 2 equals 8. Okay? The fourth root of 81 is also 3. Because 3 times 3 times 3 times 3 equals 9 times 9 equals 81. And the third root of minus 27 is minus 3. Minus 3 times minus 3 times minus 3. Okay? So these are ones you should memorize also. Write them in your book when we're done. Okay, and then the last part of this lesson is this kind of affair where we have to evaluate a string of things, okay? So we go in order of operations. We're going to want to take care of our roots and powers first, and then we'll go back and do the addition. So we'll handle each one of these individually. Okay, this minus sign is not protected, so I cover it up. 2 squared is 4. I lift my finger away and it becomes minus 4. Okay, I'm going to copy this plus sign down. Now this minus sign is protected by parentheses, so I can't cover it up. It goes along for the ride. Minus 3 times minus 3 is positive 9. So that goes there. Square root of 4 is 2. But it tells me to both add and subtract it. What that means is that I'm going to have 2 answers. I'm going to calculate this once as minus 4 plus 9 plus 2. And then I'm going to calculate it again as minus 4 plus 9 minus 2. Like so, right? So then we just do these additions. This would be 7, right? And then this one would be 3. So we can write our answer like this. 7 and 3 are the answers. Yay! This is pretty hard. The rest of what we did is fairly straightforward, and it's just going over what you need to commit to memory. This evaluation thing is tricky because you have to remember the rules on what you can cover up and what you can't cover up, and then you have to deal with this wonky plus or minus scenario. And remember that it means you have 2 different answers to calculate. That's lesson 62. We did it. Yay! We're halfway through the week. Oh my gosh, it's flying by. Thank you, students. See you next time.